Hello everyone. So my name is Anita Okele, and today we'll be talking about identity and access management. So basically understanding identity and access management in cloud and DevOps environments. We're going to be looking at what is IAM, core components of IAM, principle IAM, how IAM works, policy, role, user, authentication methods, IAM authorization models, IAM in DevOps and cloud, some best practices, common IAM threats and misconfigurations, then why IAM is crucial in DevOps. So let's start with what IAM is. IAM refers to Identity and Access Management, and it is a framework of policies, processes, and technologies that ensure the right people have the right access to the right resources at the right time. So IAM helps to prevent unauthorized access and data breaches. IAM also enables accountability and compliance, and also helps with secure collaboration between internal and external users. So let's talk about the core components of IAM. So we have the identity, authentication, and authorization. So for identity, we are referring to the user, the application, or the service. For authentication, it verifies who you are, speaking to passwords, multi-factor authentication, and the like. Then authorization defines what you can do, permissions that are allowed on a service. And then moving to some of the principles of IAM, we have the least privilege, separation of duties, and zero trust. So for least privilege ensures that a user, application, and system have only the minimum access necessary to perform their legitimate tasks, reducing risk and enhancing security. So you give the users only what they need, nothing more, nothing less. Then separation of duties divides critical tasks among multiple roles to prevent fraud, errors, and unauthorized actions, ensuring accountability. So for separation of duty, you do not give one person more than enough access so they to reduce misusing the system. And then for zero trust, it is a security model that never trust any user or device by default. So you continue um, always require verification and to monitor and protect against threats. So you always verify, never trust. Moving on to how IAM works, so the user logs in, then IAM confirms that the user has inputted their rights, credentials, their password, their token, their OTP, and then IAM now verifies the user's role or policy. Then IAM grants or denies access to the resource. So let's talk about what policy, role, and user is. So for policy, the policy defines permissions. So what actions are allowed or denied on which service. Just think of it as the company's rules, and then the role is like the job title. So the role aggregates these policies for assignment to users or services. And then a user, which is like the employee, now inherits those permissions from the assigned roles. So the user inherits the roles that the policy was attached to. So let's say, for instance, you create a policy of read or write as allow read or write access to a database, and you attach that policy to a role like a developer role, and then a user, maybe let's say Anita, will now inherit that role and will be able to have read or write access to the database. So we have different authentication methods. We have the username and password, the multi-factor authentication, the biometric authentication. We have single sign-on, risk-based, adaptive authentication, and location authentication. So let's speak to the IAM authorization models. We have a lot, but I'll just pick to these four. So we have the role-based access control. So this is access is being assigned based on roles, and each role has a predefined permission. So users inherit permissions when they are assigned a role. Then we have attributes-based access control. So the access is based on attributes of the user, resource, environment, or action. And the policies define which combinations are allowed. So for attributes, you can say if this user is under the finance team and logs in at this location and uses the computer network, you can allow access. So that's basically what attributes-based access control is. Then policy-based access is determined by centralized policies, often written in a formal language like JSON, the YAML, and these policies can be applied dynamically to users or roles. We have the mandatory access control. So for this model, the access decisions are strictly controlled by central authority. Users cannot override permissions and they are used in high security environments like in the military. So let's move on to IAM in DevOps and Cloud. So for IAM in DevOps and Cloud, we can see IAM in CI/CD tools like Jenkins, GitHub Actions, and GitLab. So these tools, they need permission to deploy applications, and you can use IAM in for that. Then DevOps team, they deploy infrastructure to cloud platforms, and IAM controls who can create servers and deploy applications. Then IAM in the cloud manages identities and permissions to ensure only authorized users, applications, and services can access cloud resources securely. IAM integrates with login systems to record who accessed resources, what actions were performed, and when, enabling security monitoring, incident investigation, and compliance. So move on to the best practices of IAM. So some of the best practices, there are lots, but let's just speak to this for. So one of the best practices is to always automate IAM processes within CI/CD pipelines. So you can attach these policies to your Terraform code and trigger your CI/CD pipeline. So you don't have to be manually doing creating these IAM roles and IAM policies. Um, maybe um, like maybe just if you create it manually, there is room for error. So it's better to automate the IAM processes. Then also enforce least privilege for all users and service. We spoke about least privilege, so don't give one user more than what they need. Just give them the minimum access required to perform their function. Implement strong passwords and MFA, yeah, and then always audit and review permissions. Moving on to some of the common threats, IAM threats and misconfigurations. So overly broad permissions. For this overly broad permission, for example, when you're creating your IAM policy and you want to grant access to a user or a resource and um, you put your action as star. Star is like a wild card. So you are basically saying allow all actions. So if your effect is allow and you put action as star, you're saying allow all actions on. And then the resource you put star again, and that's like allow all action on all resources. So it's best to always specify what action you want to be allowed and what on what resource. Shared or static credentials. So sharing your passwords and keeping your password for too long. So most times it's always advisable, like always try to change your password maybe every 30 days. It's advisable, or you can set it that, oh, every 30 days, it should always prompt you to change your password so you don't forget. Lack of MFA on admin accounts. So for admin accounts, you need to set up your multi-factor authentication, expose access keys in code repositories. So when you're pushing your code to GitHub, GitLab, always try to make sure you use like an env file keep your codes or you store them in the GitHub credential, secrets and credentials. Then forgotten. Okay, so Olalekan Adeyemi, the topic is IAM in cloud and DevOps. So forgotten inactive users. So if there are users that maybe they've left the system, it is very advisable that you take off their profile from the system so they won't have access anymore. And missing audit trails or log monitoring. So why is IAM crucial in DevOps? So IAM helps with secure automation, helps with helps to protect services, protect secrets, sorry, and help with compliance and enforces least privilege. So for secure automation, a pipeline may be allowed to deploy an application but not delete a database. Then for protecting secrets, you can integrate IAM with the secrets manager to ensure that only authorized systems can retrieve crucial secrets and credentials. And then IAM helps with compliance. So you can see which user, service, account, or pipeline modified a production resource. So with IAM, a developer may deploy to development environments, but only an operations team deploys production. So that's enforcing least privilege. So in summary, so just think of IAM as a digital security guard for your company's computers, apps and cloud. And it makes sure that the right person, which is the identity, that's the user, gets into the right place, has the access at the right time, and only does what they are allowed to do. So IAM is about who can do what. Thank you. Is there anybody with a question? Sorry, Olaleko. The title is IAM in Cloud and DevOps. I hope I don't know, maybe you did not join earlier. That's the title. If you have any question, you can ask if anyone has any question.